Morning students, we are discussing chapter enzymes, right? In this enzymes chapter, go for the next topic, chemical reactions. What's that? Chemical reactions, right? Sir, a chemical compound undergoes two types of changes. A chemical compound undergoes two types of changes. A chemical compound undergoes how many types of changes, sir? It undergoes two types of changes. Okay. Sir, what are these two types of changes? Right. Number one. First one is a physical process. What is a physical process? Second one is a chemical process or chemical reactions. Okay. Go for the first one. What is a physical process? What it is a physical process? Go for physical process. Okay. Sir, what is the meaning of this physical process, sir? In this process, a substance or a chemical compound changes its shape or changes its state. Therefore, change in either shape or state of a chemical compound. Okay, right? It means chemical compound. What's a chemical compound? Sir, a chemical compound, what it is doing, sir? A chemical compound changes. Chemical compound changes its what? Chemical compound changes its shape or changes its state. Okay. Sir, when a chemical compound is changing its shape, the bonds that are already present in this chemical compound are not broken. Therefore, without breaking of bonds, there is a change in the shape of chemical compounds. Therefore, with or without, sir? Right, without. What, sir? Without breaking of bonds. Is this statement okay? Sir, physical process means change in either shape or state. While a chemical compound is changing its shape, the bonds present in that chemical compound are not broken without breaking of bonds. Now go for the second one. What is, sir? Change in state. Sir, what is the meaning of here change in state, sir? It means a chemical compound is changing its state. For example, take ice. Sir, ice means it is in which state, sir? Solid state. Yes or no? Which state, sir? Solid state. Sir, when this ice is going to melt, when this ice melts, what we are going to get, sir? Water. Yes or no? Sir, this water, which state, sir? It is in liquid state. Which state it is? Liquid state. Sir, if we heat this water, what you will get? You will get water vapor. What we are getting, sir? Water vapor. Sir, this water vapor, it is in which state, sir? Gaseous state. It means a chemical compound is changing its state in this example, changing its state from solid to liquid to gas. Either change in shape or change in state comes under which process, sir? Physical process. Physical process, right? Right. Now go for number 2, chemical process or chemical reactions, right? chemical process or chemical reactions. Chemical process or what are chemical reactions? Sir, during chemical reactions, already existing bonds in a chemical compound are broken and new bonds are formed. Therefore, during chemical reactions, breaking and formation of new bonds takes place. What? During chemical reactions. During chemical reactions? During chemical reactions, what happens? Making and breaking. Making means formation here. Okay. Therefore, making and breaking of bonds. Okay, right. It means new bonds are formed. Already existing bonds are broken. Right. Sir, these chemical reactions are of two types. Which reactions? Chemical reactions. Chemical reactions are of how many types, sir? Two types. Chemical reactions are of two types. They are of two types. Sir, what are these two types of chemical reactions, sir? First one is inorganic chemical reactions. Second one is organic chemical reactions. What is the first one? Inorganic chemical reactions. Inorganic chemical reactions. Inorganic chemical reactions. Second one is organic chemical reactions. Organic chemical reactions. Therefore, chemical reactions are of two types. What is the first one? Inorganic chemical reactions. In our textbook, one example is given. BaOH twice barium hydroxide reacts with H2SO4 sulfuric acid to form barium sulfate BaSO4. Okay, right, sir. Next, what more is formed, sir? Water. What is formed, sir? Water is formed. What is formed here? Water is formed. Okay, right. Therefore, see this reaction once. Sir, in this reaction, when BaOH twice reacts with H2SO4, then what is formed? BaSO4 is formed. Yes or no? Sir, to form BaSO4, first the bonds in this chemical compound should be broken. After breaking bonds in this and this chemical compounds, then by forming new bonds, BaSO4 is formed. Yes or no? This is inorganic chemical reaction. Now go for organic chemical reactions. Sir, take starch. Starch is a polysaccharide. It is a polymer of glucose. When you hydrolyze this starch, what is obtained? Glucose is obtained, because starch is made up of glucose units. Yes or no? This hydrolysis of starch to produce glucose is an example for what, sir? Organic chemical reactions. Therefore, what, sir? Hydrolysis of starch yielding what? Glucose. This is an example for what, sir? Organic chemical reactions. Hydrolysis or hydrolysis of starch to produce glucose is an example for what, sir? Organic chemical reactions. Therefore, sir, a chemical compound is undergoing two types of changes. First one is a physical process. Second one is a chemical process. Whether it is physical or chemical, the amount of product formed per unit time, formed per unit time is called rate of reaction. What it is called as? Rate of reaction. Right? Therefore, whether, okay, either it is physical or chemical. Either physical or chemical. Right? Amount of amount of what? Amount of product formed per unit time. Amount of product formed per unit time. Amount of product formed per unit time is called what, sir? Rate of reaction. Therefore, what is the meaning of rate of reaction? Amount of product formed per unit time is called rate of reaction. Sir, how we can represent this rate of reaction, sir? Amount of product formed per unit time. Yes or no? This is called as what, sir? Rate of reaction. This is called rate of reaction. What it is called as? Rate of reaction. Sir, this rate of reaction is influenced by temperature. Rate of reaction is influenced by what, sir? Temperature. Influenced by temperature. Right? Right. Sir, rate of reaction influenced by temperature. Rate of reaction influenced by temperature. Sir, how you are saying that this rate of reaction influenced by temperature, sir? If you take a general thumb rule, according to thumb rule, for every 10 degrees rise in temperature, that is increase in temperature, rate of the reaction doubles. For every 10 degrees rise in temperature, that is increase in temperature, rate of reaction doubles. Rise in temperature, rate of reaction doubles. For every 10 degrees Celsius decrease in temperature, rate of reaction halves. Halved. Okay, right? Therefore, as per general thumb rule, okay, right? For every what? 10 degrees Celsius rise in temperature. For every 10 degrees Celsius rise, nothing but increase in what's our temperature. What happens? Rate of reaction doubles. Rate of reaction. What happens? Rate of reaction doubles. Sir, what is doubled, sir? Rate of reaction is doubled for every 10 degrees Celsius rise in temperature. For every, right, for every 10 degrees decrease in temperature, for every 10 degrees Celsius, right, decrease in, what's sir? Decrease in temperature, what happens? Rate of reaction is halved. What is halved, sir? Rate of reaction. Rate of reaction is halved. What is halved, sir? Rate of reaction is halved for every 10 degrees Celsius decrease in temperature. These statements clearly indicates that rate of reaction is influenced by temperature. Rate of reaction is influenced by temperature. Okay. Sir, compared to uncatalyzed reactions, catalyzed reactions proceeds with a faster rates. Therefore, sir, catalyzed reactions means enzymatic reactions proceeds at a faster rates than uncatalyzed reactions. Okay, right? Right. Catalyzed reactions. Catalyzed reactions proceeds with a what, sir? Proceeds with a faster rates than what? Uncatalyzed reactions. Uncatalyzed reactions. Therefore, who are proceeding with a faster rates, sir? Catalyzed reactions than what, sir? Uncatalyzed reactions. How we are saying this statement, sir? For example, take a reaction that is H2O plus CO2, right? Sir, when these two reacts, carbonic acid is formed. H2CO3. What is formed, sir? Carbonic acid. carbonic acid is formed. Okay, sir, this is in the absence of enzyme. So this is which reaction? It is uncatalyzed reaction. Uncatalyzed reaction. This is uncatalyzed what, sir? Reaction. Sir, in this uncatalyzed reaction, what is formed? Carbonic acid, right? Sir, 200 molecules of carbonic acid, 200 molecules of what? Carbonic acid formed. 200 molecules of carbonic acid formed in 1 hour time. 1 hour, that is 60 minutes. Therefore, in 60 minutes of time, write 200 molecules of carbonic acid formed. This is in the absence of enzyme, that is uncatalyzed reaction. But you take the same reaction but in presence of enzyme. Same reaction I am taking but in presence of enzyme, that is enzymatic reaction or catalyzed reaction. Catalyzed reaction. What is that catalyzed reaction, sir? What is that catalyzed reaction here? Water, that is H2O. Carbon dioxide, that is CO2, gives rise to what, sir? H2CO3, that is carbonic acid. H2CO3, that is carbonic acid. Carbonic acid. What is the change in this and this reaction, sir? This is in presence of an enzyme by name what's our carbonic anhydrase. What is the enzyme name? Carbonic anhydrase. Carbonic anhydrase. This is a catalyzed reaction. Carbonic anhydrase enzyme is a cytosolic enzyme present inside the cytosol. It is a cytosolic enzyme. Carbonic anhydrase, it is a cytosolic enzyme. What it is, sir? It is a cytosolic enzyme. It is a cytosolic enzyme present inside the cytoplasm. Cytoplasmic enzyme, we can call even it as cytoplasmic enzyme. Okay, right. Now listen this statement. Sir, in presence of carbonic anhydrase enzyme, right, 6 lakhs of carbonic acid molecules are formed just in 1 second time. Just in 1 second time. 6 lakhs of carbonic acid molecules are formed in presence of carbonic anhydrase enzyme. Right, how many, sir? 6 lakhs. How many, sir? 6 lakhs of what formed, sir? Carbonic acid molecules. Carbonic acid molecules formed in how much time? In 1 second time. It means this enzyme, right, accelerates the rate of reaction by 10 million times. It has accelerated the rate of reaction by 10 million times. Sir, here 200 molecules of carbonic acid in 1 hour time. Here 6 lakhs of carbonic acid molecules in 1 second time. It means this enzyme has accelerated the rate of reaction by 10 million times. By 10 million times, right? Therefore, enzyme accelerated. Enzyme, what's that? Accelerated what? Rate of reaction. Enzyme accelerated what? Rate of reaction by how many times? 10 million times. Okay, therefore enzyme what's our accelerated right rate of reaction by 10 million times. Okay, now see here, sir, A is a substrate, sir, converted into B, sir. Sir, this B again converted into C, sir. C again converted into D, sir. This is a multi-step chemical reaction. Yes or no? Multi-step chemical reaction. Multi-step chemical reaction. Multi-step, many steps are involved. Sir, in these many steps, each step is either catalyzed by same enzyme complex, I am saying complex, same enzyme complex, or catalyzed by a different enzyme, same enzyme complex or catalyzed by different enzyme. These multi-step reactions which are catalyzed by same enzyme complex are what? Different enzymes called as metabolic pathway. What it is called as? Metabolic pathway. In first year we read one statement. Metabolic pathways may be either linear or circular. Metabolic pathways may be either linear or circular. Yes or no? Right. Therefore, a multi-step what? Chemical. Multi-step chemical reactions. Multi-step chemical reactions in which each step catalyzed. Each step catalyzed by a what? Each step is catalyzed by a what's our enzyme complex, catalyzed by a single enzyme complex, catalyzed by a single enzyme complex or by a different enzyme. It means each and every step is catalyzed by a different enzyme. Catalyzed by a different enzyme. These multi-step chemical reactions in which each step is catalyzed either by a single enzyme complex or by a different enzyme is called as metabolic pathway. What it is called as? Metabolic pathway. Metabolic pathway. Sir, these metabolic pathways, they may be either linear or circular. Yes or no? Metabolic pathways are either linear or what's circular. They may be either linear or circular. Okay. Now see this statement ma. Sir, take a glucose. What sir? Glucose. I am taking one glucose molecule. Sir, what is the formula of glucose sir? C6H12O6. Yes or no? What is the formula of glucose? C6H12O6. C6H12O6. Sir, this glucose is broken to form two molecules of pyruvic acid. Breaks to form what sir? Two molecules of pyruvic acid. Two molecules of pyruvic acid. Okay, right. Sir, this pyruvic acid, what is the formula of pyruvic acid, sir? C3H4O3. This is the formula of pyruvic acid. Sir, this one glucose molecule producing two pyruvic acid molecules, right? This is glycolysis or glycolysis. Glycolysis or glycolysis. Sir, this glycolysis, it involves, right, 10 reactions. Involves how many reactions, sir? 10 reactions. Involves 10 reactions. Okay. Here each and every reaction is catalyzed by a different enzyme. 10 reactions catalyzed by 10 enzymes. 10 reactions in glycolysis catalyzed by 10 different enzymes. Catalyzed by 10 different enzymes. Right? Right. Sir, one glucose molecule converted into two molecules of pyruvic acid by glycolysis. Sir, I am writing this equation for glycolysis, sir. Right, C6 what? H12O6 plus O2, right, gives rise to what, sir? C3. How many molecules? Two molecules, right? We will write C3H4O3 plus 2H2O. 2H2O. Here how many pyruvic acid molecules we got? Two pyruvic acid molecules we got. Yes or no? Right? Sir, now this pyruvic acid which is formed by this glycolysis reaction, it undergoes either complete oxidation, right, or it undergoes anaerobic respiration. Undergoes anaerobic respiration. Sir, pyruvic acid. Pyruvic acid. How many pyruvic acid molecules we got? Two pyruvic acid molecules. Sir, these two pyruvic acid molecules, these two pyruvic acid molecules either enters which respiration? Aerobic respiration. Pyruvic acid either enters a what sir, aerobic respiration, right, or undergoes a anaerobic respiration. Sir, this anaerobic respiration is also called as fermentation. What it is called as a fermentation. Anaerobic respiration is also called as fermentation. Sir, in general, this fermentation is of two types, sir. First one is right, alcohol fermentation. What is the first one? Alcohol fermentation. Okay. Second one is acid fermentation. What is the second one? Acid fermentation. Second one is acid fermentation. Okay, right. Sir, this alcohol fermentation takes place in how many steps, sir? 2 steps. Takes place in how many steps, sir? 2 steps. Right. Sir, what is the first step, sir? In first step, what happens means these 2 molecules of pyruvic acid. What, sir? 2 molecules of pyruvic acid. 2 molecules of pyruvic acid undergoes decarboxylation. Undergoes what, sir? Decarboxylation, and produces 2 molecules of acetaldehyde. Produces what? 2 molecules of acetaldehyde, that is CH3CHO plus 2 carbon dioxide molecules. This is the first step. What is this step called as a decarboxylation? This is which reaction, sir? Decarboxylation reaction. This is decarboxylation. Now, right, go for the second step, number 2. In second reaction, what happens? These 2 molecules of acetaldehyde, reduced with the help of 2 molecules of NADH2, to produce 2 molecules of ethyl alcohol. To produce what, sir? 2 molecules of ethyl alcohol. Sir, this is the second step, sir. This step is called as reduction. What is this step called as a reduction? This is reduction. Therefore, see this statement once. Sir, alcoholic fermentation takes place in 2 steps. First step is decarboxylation, second step is reduction. During decarboxylation, 2 molecules of pyruvic acid produced 2 molecules of acetaldehyde. During reduction, these 2 molecules of acetaldehyde is reduced by using NADH2. So, NADH2 is a reducing agent as it has reduced acetaldehyde. To produce 2 molecules of what, sir? Ethyl alcohol. Right? Now go for number 2. What's our acid fermentation? What it is? Acid fermentation. Go for acid fermentation, right? Now listen this statement. Sir, during which fermentation, sir? Acid fermentation, right? Reduction takes place. Only one step is involved. What is that step, sir? Reduction. What is that step, sir? Reduction. What it is? Reduction. Here what happens means 2 molecules of pyruvic acid. What it is? 2 molecules of pyruvic acid is reduced by using 2 molecules of NADH2. To produce what, sir? To produce 2 molecules of lactic acid. To produce 2 molecules of what, sir? Lactic acid. 2 molecules of lactic acid. Okay, right? Therefore, sir, acid fermentation, only one step, that is reduction. 2 molecules of pyruvic acid reduced by 2 molecules of NADH2 to form 2 molecules of lactic acid. Sir, in this reaction, lactate dehydrogenase enzyme is involved. Why I am speaking about enzyme here? Because this is a isoenzyme. In introduction I told, right? What it is, sir? Lactate or lactic dehydrogenase. Lactate or lactic dehydrogenase enzyme. Okay, sir, if you proceed right for which respiration? Aerobic respiration, then pyruvic acid completely oxidized. pyruvic acid, what sir, completely oxidized. Pyruvic acid is completely oxidized to form carbon dioxide and water, to form what sir, carbon dioxide and water. Therefore pyruvic acid, right, either enters into aerobic respiration where pyruvic acid is completely oxidized to produce carbon dioxide and water, or it enters into anaerobic respiration, nothing but fermentation, which undergoes either alcoholic fermentation or acid fermentation, right? Thank you.